Okay, welcome back. Today I am going to discuss about inertia, force and laws of motion. Okay, so this particular chapter, actually the introductory part, you can say it is available in CBSE 9th standard syllabus. Okay, so this particular class will be even useful for them also, and even it is useful for others also. Okay, so to clarify the basics of, you can say, inertia, force and Newton's laws of motion, that I am going to discuss today. So I am going to discuss about inertia, then what actually is the force, and then I am going to talk about Newton laws of motion. So these three things I am going to discuss today. Okay, so once again I welcome everybody in my class, and I hope that whatever classes I have conducted till now, everybody would have understood and they are understanding it in a very well manner. Okay, I am trying to put my full effort so that they can understand very clearly in a very simple language I used to explain to them. Okay, let us see. So the very first topic is inertia. Okay, so inertia. So for the information of my students, what I want to say, that any body or any object, what is the natural tendency of that particular object is to remain in that position only. Okay, it doesn't want to change its position. So it may be in motion, it may be at rest. So anything can happen. If it is in motion, it will try to continue in motion. If it is at rest, it will try to continue to be at rest. So this is the natural tendency of each and every body or each and every object, I can say. Even human being also, If we are sleeping, okay, and we have to get up at 6 o'clock, our mind will say, no, let us sleep up to 6:10, 10 minutes more, 20 minutes more. Okay, and sometimes it happens that we thought about 10 minutes and after that I will get up. After 2 hours, suddenly we are getting up and we are finding that we have slept for 2 hours. Okay, so even human body is having that particular tendency to remain in that particular position. Right? Okay, so what we do, if we are getting up and we start doing the jobs and all, it means we have created some external effort. We start doing something extra from outside, which makes the body do work. Whereas, earlier case, if I am sleeping, I want to sleep. Of course, one more condition, yes, very good. I told you that any body, if it is in motion, so it will continue to be in motion, but for human body, there is a limitation, gentlemen. Of course, I do agree with this. And for human body, actually, this particular criteria is not applied. Means, if it is in motion, we will continue to be in motion. No, it's not like that. If we are working, so we will continue to do that work without taking rest, without having food and without drinking water and other things, okay, without recreation. We will keep on doing the same job 24 hours, 365 days. Of course, it is not possible. Not possible, of course, very good. I am talking about any non-living object. Okay, so now I am modifying my definition. Okay, so inertia is what? Is the inherent tendency, is the internal tendency of the object. So that tendency to be in the same condition what it was. This is called inertia. This is called inertia. Okay, this is called inertia. So it is the internal property. So for an example, if you say, if some rock is there, and that particular rock, if from outside it is not disturbed in any way, even after 100 years, even after 200 years, till the existence of earth, that rock will be at the same position. It will be at the same position. Another, I told you, the example for rest. If the object is at rest. Then another one is a very good life example I am saying, and that is Earth revolving around the Sun. Earth revolving around the Sun, or the rotation of Earth around its own axis. So what it is? It keeps on rotating around its own axis. Simultaneously, it keeps on revolving around the Sun. It is not stopping of its own. It is not stopping. So it keeps on revolving. So this is the live example. Even moon revolves around the Earth. So it is a live example of this inertia. Okay? So I already told you. So what actually is an inertia? It is the tendency. How can we define? We can define inertia as the tendency or property of an object. Of an object. Of an object, due to which the object tends to maintain its position. Tends to maintain its position. Okay. Be at rest or in motion. So I hope my students, those who are watching this particular video actually, they would have understood in a very nice manner that what actually is inertia. What actually is inertia? See, we are studying the chapter of force and Newton's laws of motion generally. So if we need to know about force, we compulsorily should know about inertia. Compulsorily we should know about inertia. So this inertia, what we have studied today, what we are studying now, it is the tendency or property of an object, due to which the object tends to maintain its position, be at rest or in motion. Okay, so example, let us see example. So for rotation, we will be writing that Earth revolving around the Sun. A stone on a plane surface. Even this chair, the table which is available here, these all are static. Until unless we are not moving this particular chair or table, it will not move. Even after 100 years, yes, even after 100 years, 200 years, till the time the earth is existing, it will remain in its position. Then you may say, sir, I can say that one live example, it may change its position. So what? Sir, earthquake will come. Okay. So that particular case, in that earthquake is coming, it means something additional, extra effort has come here. Extra effort is being applied on this particular table. Yes or no? Okay, if a high velocity wind is blowing over this particular chair or table, so it will change its position, of course. So what we are doing? We are doing some external effort, force. We are doing some external effort to change its position. Otherwise, naturally, it doesn't want to change its position. It wants to remain just like Kumbhakarna. कुंभकर्ण एक बार सो गया 6 महीने के बाद ही उठेगा, लेकिन वो उठ जाता था. In this case, it will not be like that. In this case, so at that time what was there? कुंभकर्ण after 6 months जाग गया. अब उसको पूरा क्या चाहिए? फूड चाहिए कि नहीं? ठीक है. Similarly, इस पर्टिकुलर ऑब्जेक्ट को अगर चेंज करना है इसके पोजीशन से, if we want to change its position, we need to apply one additional force, extra force. That is there. Okay. So, gentlemen, this is the tendency or property of an object due to which the object tends to maintain its position. That is what inertia. And inertia is due to what? Now the question arises that inertia is due to what? Why it wants to maintain its position? So actually inertia is due to the matter contained in the body. And the matter contained in the body is what? It is mass. What it is? It is mass. Okay. So mass, actually what it is? So mass is what? Matter. Matter, you know? You know or not matter? So matter is what? Matter means substance. Okay, the substance which contains molecules. Which contains molecules. That molecules may be tightly packed. Solid. That is what? Solid. The molecules may be loosely packed in comparison to solid, that is called liquid. Further it is loosely packed, random motion, it is having more random motion, the molecules in that particular matter. What is gas? All are the phases of or states of matter. What it is? We call it as states of matter. And this matter is made of very tiny, indivisible. Matter is made of tiny, बहुत छोटा. दिखेगा भी नहीं, हमको नहीं दिखेगा. नहीं दिखेगा? Yes, दिखेगा नहीं. It will not be visible. Matter is made of tiny particles, and that too it is indivisible further, and which is given the name as atom. Atom. All matters are made of tiny, indivisible particle called atom. Okay? Right. So mass is what? Mass is the matter contained in a body, and matter is what? Either it may be solid, it may be liquid, it may be gas, and then solid, liquid, gas. It is consisting of what? It is consisting of molecules. It is consisting of molecules. In solid it will be tightly packed. Molecules are not having any type of motion in solid. In liquid, molecules are little moving. Okay, so that's why it flows from one place to another, whereas solid doesn't flow. Then gas does move moving everywhere, man. Without gas, without air, will not be able to live. Right? Okay, correct? So without gas, without air, will not be able to live. We get oxygen only from air. So that's why these all three are there in the matter. So matter contained in a body. So which is called mass. And this inertia is due to the mass of an object. Okay, so inertia is the property of mass of the body. And for your kind information, all of you gentlemen, mass is never changing. Mass will not change. Whether it will be on Earth, whether it will be on Moon, whether it will be on Mars, whether it will be on Mercury, whether it will be on Jupiter, anywhere. Mass is not going to change for anybody. Then what is changing? Weight. I am not telling you to wait for longer time, gentlemen. It is weight. It is weight. So this weight is changing, and it is only due to the acceleration due to gravity. G. Acceleration due to gravity. If you are remembering, I have told you in my video of gravitation. So what actually is changing? Mass never changes, but weight is changing. So on Earth, this G value is more, acceleration due to gravity is more, 9.8 meter per second square. The value is more than its value on Moon. Its value on Moon. So that's why we say that if my weight is 60 kg on Earth, then on Moon, what will be my weight? So it will be divided by 1 by 6 into 60, and which is giving you 10. So my weight will be 10 kg on Moon. It means 1/6 of the weight of the Earth will be the weight on the Moon. Okay, right? So a little bit we are deviating from our path. But all these things are needed, gentlemen. All these things are needed. Once the concept is very clear, there will not be any problem in understanding. And I am telling you that once you have understood it in this manner, whole life, I am telling you, gentlemen, whole life you will not forget. Whole life you will not be forgetting this. Whether in sleep somebody is asking, or whether you are in awakened state or active state, anybody is asking, immediately you will be able to answer this concept. So what actually is needed now at present for everyone, I am telling, this is only my suggestion, gentlemen. Whatever you are reading, whatever you are studying, make it once and last. How? To go more deeper and deeper, do not leave that particular topic until and unless you have not understood it 100%. I am telling you about 200%. 200% you need to understand it. Not 100%. 200% you need to understand it. 1000% you need to understand it. 1001th time you should be independent to explain this. Okay, so this particular zeal and enthusiasm, effort, hard work is required. There is no substitute for hard work. Say, okay, right, very good. So let us come to our main topic now. So inertia, everybody has understood, and it is due to the mass. Right, very nice. Let us go to the other topic which I want to discuss here. Then we will be discussing about Newton's laws of motion. Okay. So now we will be discussing discussing about force. Now, as I told that due to the internal property of the body, that particular body doesn't want to change its position. Right, but we want that body to change its position. We want the body to change its position. That changes in position will be of different, but we want. Now, if we want the body to change its state, it's not only its position. Change its state. If it is in motion, I want to stop it. If it is at rest, I want to move it. If it is running at very high speed, then I want to slow down. If it is of having some circular shape, I want to change its shape. There may be many cases are there in which some changes can be brought. So those changes we need to bring it for fulfilling our needs. For that case, what actually is required? For that case, we need something extra, additional, external. So if the body is there, remains static, I want to change its position from this A, I want to change its position to B. Okay, so this particular body only I want that it should come to B position. In our home, we are changing the position of bed, we are changing the position of dining table, we are changing the position of boxes and all. So what we do? We want this particular body to change its position. And that changing in position can be done only when we are putting some type of external effort from our side. External effort, either we are pushing it or we are pulling it. Two cases may be there. Okay, either we will be giving that force in some other direction. So this external effort is called force. Is called force generally. So the external effort applied to a body. How can we define force? The external effort applied to a body or an object to change its state, to change its state. So its state means it may be at rest, it may be at rest or motion. This external effort is called force. Is called force. Okay, so you may be remembering I have uploaded one video of turbojet engines. In that also I have discussed about force. So force is very important, gentlemen. Okay, right. So let us see the force, the external effort applied to a body or an object to change its state. Okay. Now, what will be the effect on the body? What will be the effect on the body by applying some external effort? So effects. So if the body is in motion, the body can come to rest. So the body can be stopped if it is in motion. The body can be stopped if it is in motion. Second, the body can be made to move if it is at rest. Okay. Then the body can be slowed down if it is moving at higher speed. This external effort can even change the shape and size of the body. The shape and size of the body can be changed. So we have seen that these are the possible effects. Okay, these are the possible effects of this external effort. And even one can say that we can even change the direction of the body, direction of motion, the direction of motion of the body can be changed. Can be changed. Force, an external effort applied to a body or an object which can change its state. What will be its effect? Body can be stopped if it is in motion. The body can be made to move if it is at rest. The body can be slowed down if it is moving at higher speed. Or if it is moving at higher speed, vice versa. If it is moving at slower speed, it can be accelerated. And the shape and size of the body can also be changed if we are going for some pushing force, or you can say compressing force, or a tensile force if we are applying. So another one is the direction of motion also can be changed. So these will be the effect of force. So from inertia we came to know about force. So inertia is the first property which is making the body to stay at the same position whether it is in motion or it is at rest. It is at rest. Then comes to force, which is required to move the body from its position or to change its position. Okay, or if it is in motion, it can be slowed down, it can be further accelerated, the shape and size also can be changed. So for that we need a force. Okay, so I hope everybody would have understood very clear about that inertia and force. Now let us see the next topic which I am going to describe now. For today what we have scheduled, that the third point, and the third point is Newton's laws of motion. What it is? Newton's laws of motion. Right, so let us have a discussion on Newton's laws of motion. Laws of motion. Right, very good. So the same Newton, Sir Isaac Newton. Yes, of course. So who saw the apple falling down from the tree? Okay, and he started thinking that why the apple has fallen down. So some type of gravitational force is acting. Okay, so Newton's laws of gravitation also came out in that place. Okay, so Newton's laws of motion. So Newton and Galileo, actually, both of them have developed some type of theory. Different theory, both the theories are a little different, Newton and Galileo. And they described that why the earth revolves around the sun in the same orbit. The orbit is not getting changed. Similar to the electrons which revolves around the nucleus. Right, okay, let us see. So there are three laws of motion which was given by Sir Isaac Newton. Now the first law, please remember this one, inertia. Okay. So every body continues to be in a state of rest or in motion unless acted upon by some external force to act otherwise. So what it is, in law of inertia or in Newton's first law, so Newton's first law of motion, we talk about inertia and then we talk about that how the body will change its position. So it's only due to the external effort. Okay, so So this is giving us a concept of force. This particular law, Newton's first law, is giving us the concept of force. Okay. Now second law. So before Newton's second law, Newton's second law of motion, when we are going to define Newton's second law of motion, so before that we must know about one more physical parameter is there, and that is called momentum, which is called momentum. So that momentum we must understand, and then only we will be able to understand this Newton's second law, because this Newton's second law is giving us the formula to find the force. It is making us to derive the expression by which we will be able to calculate the amount of force required to move an object when it is in motion or when it is at rest. Okay, so that particular part is giving us, so here only concept of force has come, but here Newton's second law of motion is making us to calculate the amount of force. Calculate the amount of force, which it is giving us as a mathematical expression. Okay, so that mathematical expression F is equal to ma, it is given by Newton's second law of motion. Okay, so before that, as I told, momentum we need to understand, and momentum is what? Product of mass and velocity. The product of mass and velocity of a body is called momentum. Is called momentum. So momentum is generally denoted by P, and which is mass and velocity. So mass of the object and V is the velocity. So what will be its SI unit? SI unit is kg meter per second. So the unit of mass is kg, the unit of velocity is meter per second. So its SI unit of momentum is kg meter per second. So product of mass and velocity of a body is called momentum. So if the body is at steady, means velocity is zero, what will happen? The momentum will be zero. So compulsorily, if we need some momentum, we need to have velocity. We need to have velocity. Okay, if we can say that mass, so if mass is zero, again momentum will become zero. So nothing should be zero here. Mass also should be there in the body, velocity also should be there. Then only we will be able to calculate momentum of a body. Okay, right. Now from this particular definition, we are going to derive a mathematical expression which is given by Newton's second law of motion. And Newton's second law of motion, what it says that the rate of change of momentum, is directly proportional to the applied force on a body. So Newton's second law is making us to derive an expression for force. So it says that the rate of change of momentum is directly proportional to the applied force of a body. So we can say that F is directly proportional to dP by dt. dP by dt. dP by dt is what? So this will give you F. We can write it as K, and d P we will be writing as mv by dt because m is here. And as mass is constant, further I am writing here. So we can write F is equal to K. K is what? K is a proportionality constant. K is proportionality constant, and as mass is also constant, that M will be coming out, and we can write it as dP by dt. dP means what? Change in velocity. dt means what? Change in time. Okay. So there will be a time change. If the velocity v1 is at time t1, and if the velocity is at v2 at time t2. So what is the change of velocity? v2 minus v1, which is called as dv. Okay, so here we can write as dv is equal to v2 minus v1, and dt is equal to, we can write t2 minus t1. Okay, so this dv by dt is what? Rate of change of velocity is what? It is acceleration. It is acceleration, gentlemen. So F is equal to kma. Okay, and k is the proportionality constant, and this proportionality constant, experimentally it is found that its value will be equal to 1. Okay, as k is equal to 1, we got k is equal to 1. We are getting what? We are getting F is equal to ma. This is the mathematical expression. Force is equal to mass into acceleration, which is given by Newton's second law of motion. So inertia has made us to know about the mass. Then Newton's first, then we described about an external effort which will be changing the position of the body. So that is called force. Then when we get to Newton's laws of motion, the concept of force is clearly defined by Newton's first law. That's why it is called as law of inertia also. Then Newton's second law has made us to calculate mathematically. Algebraic expression is there through which we will be able to calculate force, which has given force is equal to mass into acceleration, that particular formula. Okay, so let us go for Newton's third law of motion. So till now we came to know about force also. Now we are in a position to calculate force. We are in a position to calculate momentum. And the last law of motion, Newton's laws of motion, that we are going to discuss, and that is Newton's third law of motion. Third law of motion. So this Newton's third law of motion is what? For every action there is an equal and opposite reaction. This particular law is telling about action and reaction. Action and reaction. If I push this board, okay, like this, if I am pushing this board, the board also pushes me simultaneously with the same force what I have applied on this particular board. Okay, so that is, so my action is I am applying a force on this particular body. What is the reaction I am getting? The board is also applying a force on my hand with that equal and opposite force. Equal and opposite force, that's why it has not moved. So in this particular case, I can say that the force is balanced. Why? Because I am applying a force, the same force is being applied by this particular board to me. Then force is balanced. Why? Because there is no movement. It is not moving. It is static. It is not moving. If I am applying a force and I will be making this particular board to move, in that case, my force will be bigger, my force will be more than the force exerted by this board on my hand. In that case, it will be unbalanced force. There are two types of forces are there. Balanced forces and another one is called unbalanced forces. Unbalanced forces. So balanced forces will make what? Balanced forces will make the body not to change its state. Balanced force will not make the body to change its state. If it is in motion and all the forces applied to that particular body are equal and cancelling each other, then there will not be any change. There will not be any change. Whereas unbalanced forces will make us to have all the effects of forces what we have studied. It will make the body to, if it is in motion, it will be stopping. If it is at rest, it will move. If it is at higher speed, it will be slowing down. It may be accelerating. It may change its shape. It may be changing its size. So all effects can occur only due to this unbalanced force. Due to the balanced force, there will not be any change in the state. Whether it is at rest or in motion, it will be remain at the same condition. So for every action, there is an equal and opposite reaction. Gentlemen, this particular law is very important. Just a few days earlier, I have uploaded my turbojet engine, one of the very great engine which is fitted on aircraft, and due to which all fighter aircraft which are flying at Mach 5, Mach 6 or Mach 3, more than Mach 3, supersonic, hypersonic, all that is possible only due to this turbojet engine. In that turbojet engine I have clearly explained that what is the effect of thrust force, and that thrust force is nothing but the application of Newton's third law of motion. I have clearly emphasized there that how Newton's third law of motion is being applied in aircraft and even in rocket, and we are watching this live example of rocket and aircraft in front of us. Only due to this, all the three laws of motions are being applied there, but the thrust force which is making it to lift upward or making it to move forward, that full aircraft body, it is only due to this Newton's third law of motion. Okay, so there will be an action, there is an equal and opposite reaction. The swimming, what we do, when we move our hand forward and pull the water towards us, our body is pushed forward with that same amount of force what we are applying to pull the water towards us. Swimming. So a very great live example you can say, so swimming. Second, rocket, lifting upward. Aircrafts, moving forward. All this due to this Newton's third law. Okay, so we have come to the end of this particular video today. I have touched the topic of inertia, force and Newton's laws of motion. We already went for deriving the formula for calculation of force. Now we are well aware that what actually is momentum. So momentum we can calculate by utilizing this particular formula. P is equal to mass into velocity. Its SI unit is kg meter per second. Then we derived due to this Newton's second law that force is equal to ma, and its unit is kg meter per second square. Why? Because the acceleration, unit of acceleration is kg meter per second square. I am talking about SI unit only, gentlemen. SI unit. And this kg meter per second is also called as Newton. Is also called as Newton. Okay? So all these particular laws, force, today we have discussed. We came to know that what actually is inertia. Then the concept of force is developed. That concept of force is being applied in Newton's first law of motion, that's why it is called law of inertia. We came to know about mass of the body, so inertia is due to the mass, and how we came to know that how the weight differs on Earth and on Moon. So we discussed about acceleration due to gravity also, so F is equal to even mg also we can write. The bodies which are falling, which are moving upward and downward. So we can write F is equal to mg also. So this g is nothing but acceleration due to gravity. Then we discussed about Newton's third law of motion, its applications already we have discussed. And you can see my video also on turbojet engines where I have described in detail, and there I described it as thrust force. Thrust force. Even in fluid chapter we will study about this thrust force, and this thrust force is the main force which is making the aircraft to move forward, which is making the rocket to get lifted upward at high velocity. Okay, so with this particular explanation of all these topics, I am stopping today, and in my next video I will be coming with some new topic. Okay, and we will solve some of the questions also based on these formulas. Okay, so till then, bye. If you have liked it, please subscribe and please share it to your friends. Thank you very much.